Okay, good morning again. So this is today's agenda. We started with 10. Hopefully everybody finished this. And this is the first lesson of the second unit for 7th grade. So we're going to start talking about today generating equivalent expressions. And this is the day one. We're going to talk about this couple days. And then you're going to have an assignment vocabulary. It's also a review about math terms that we need to know about these terms. So that's why you need to do this review. And then exit ticket, and that's all. Okay, so today's objective is I can generate equivalent expressions using the fact that addition and multiplication can be done in any order, commutative property and any grouping, associative property. If you guys remember in the other unit, commutative property was you can switch the orders when you add and multiply numbers. It's only adding and multiplying, not subtracting and dividing. Okay, and you can do the addition and multiplication also by grouping with any numbers. You can like flip the orders or changing the parentheses. So we call that associative property. So by using these two skills, we can generate like equal expressions. When it says equivalent, it's basically equal expressions. Okay, and we also talk about what is expressions in math. We know like in general meaning of expression, but what does this mean like in math class? Okay, so the essential question for this unit is how can you simplify algebraic expressions? So don't worry about this word. It's just a math expression. Okay, and if we move on, hopefully you finished it then. And let's start the first thing in this lesson. So let's say in the classroom, I know some of you guys are online, some of you are in the classroom, so we cannot do this like in real, but assume that like each envelope contains a number of triangles and number of quadrilaterals. So assume that a teacher brings you in the classroom and gives every student an envelope, and inside of those envelopes there is a number of triangles, but we don't know how many triangles, and a number of quadrilaterals, which is there is a like 4 side figures, but we don't know how many of them. Okay, so for this exercise, so we're going to label the number of triangles with T, with the first letter of triangle. So the reason why we're labeling with the letter, it's because we don't know how many number of triangles we have. If you guys remember about variables, the meaning of variable is unknown things, right? And let Q represents the number of quadrilaterals. Okay, so we have 2 variables, and let's move on. The first thing we're going to do is we need to write it down. It says, I apologize. We need to write it down, an expression using T and Q that represents total number of sides. This is the key thing. So like if you know, guys, how many sides triangle has? So every triangle, awesome, thank you so much. It's 3 sides. So each triangle has 3 sides. But do we know how many triangles in one envelope, in each envelope? Because of it didn't say the number of triangle in the description, so we're going to just label with T. If you multiply the number of sides with the number of envelopes, you're going to obtain the total side of all of the triangles, right? So, and it says the second thing is the total number of T and Q. So how many sides quadrilateral has? 4, yes, because quadrilateral means like 4 side figures, right? So I'm going to put the Q, and because of each quadrilateral has 4 sides, I'm going to multiply by 4 the number of quadrilaterals. Okay, so you already know what is total means. The total means you need to add these 2, right? So this is how you can figure out the total number of sides in each envelope. Okay, so let's move on. And the next thing, so you and your partner, let's say you're sitting with a partner and have the same number of triangles and quadrilaterals, which means Mr. John put the equal number of triangles and equal number of quadrilaterals in each envelope, and you're working with your friend, and each one of you have 1 envelope. Okay, so in this case, so we need to write it down, the expression that has total number of sides that you and your partner have, like both of you. What are we going to do the previous expression? How could you figure out the total number of for both you and your friend has it? So we already know like each envelope has like total number. It's a 3T plus 4Q, right? Because of your two, like you and your friend, your partner, because of your two, if you multiply your like total number for one of them, you're going to obtain for both of you, right? So you need to multiply by 2. Okay, and let's move on. And each envelope in the class, so it's like growing up and up, so it's getting more. Each envelope in the class contains the same number of triangles and quadrilaterals. Write that expression that represents the total number of sites in the room. So let me do the math. So in the Zoom session, I have 21 students. In the classroom, I have 1, 2, 3, 4, 5, 6 students. In total, in my classroom right now, I have 27 students. Hold on, I have one more. Okay, it's tricking me now. One more student joined also. So I have 28 students in the classroom right now. So I know each student will get how many sites of like how many total site will get. I know for each student. So if I multiply that 28 with the for each student, I'm gonna obtain for the total classroom, like for all of you guys, the 3T plus 4Q. Okay. I know a couple more students joined it, but I'm not gonna change my math anymore. I have a couple more students joined. Okay, so this is the expression we talk about. Like when we talk about expressions in math, it's actually like numbers and variables and operations are all comes together. Okay, may contain like all of them. So this is we call expression. So this is the first one, expression for each student. The second one is expression for 2 students. The last one is expression for all everybody in the classroom. Okay, so okay, let's move on. And on the next slide, we talk about. So in this case, like somebody in the classroom opened the envelope and they found a T equal 4 number of triangles, which means in each envelope there are 4 triangles. And in that envelope also there are 2 quadrilaterals. Now we know the numbers. Now we know the values of these letters. Okay. In that case, how we are going to figure out for how many sites for each student. So let's start with the first one. Let me go with different color this time. I definitely know that there are 4 triangles and 2 quadrilaterals. So we need to put these values into these letters. Okay. So for the first one, instead of T, now I need to put the number value. So it's a 3 times T was equal 4, right? So I'm going to put 4 and plus, and now we know the value for Q, it's 2. So instead of Q, I'm going to put 2. And that's it. So the first expression we call algebraic expression, okay? The reason why we call algebraic expression, it's because it contains letters. The second expression is just the numbers. So we call it just numerical expressions. Numerical means it all contains numbers. Okay, that's the difference between numerical and algebraic expressions. So we're going to talk about a lot. Don't worry about if you missed this. Here we go. So the first thing is 3 times 4 is 12. I apologize. I think you said the answer is right. Plus 4 times 2 is 8, and 12 plus 8 is 20. So in each envelope, there are 20 sites, like when you combine triangles and quadrilaterals, okay? In each envelope, there are 20 sites for each envelope. And for the second one, it's the same values, T and Q. Like instead of just plugging in all of these 4 and 2 into these variables, there is an easy way to do it. I already know how many sites in each envelope. It's 20. Because I'm trying to find the 2 students, you and your partner, you just need to multiply your each envelope with by 2, and you're going to end up with 40 sites for 2 envelopes. Okay. So for the last one, because if there are 28 students, if you multiply for like each value or unit value, it's a 20 by 28, you're going to find out in the classroom how many sites when you combine all envelopes. Okay, so it's going to be what is the twice of 28? 54, 56. Okay, 56. And put the 0 at the end because we're multiplying by 20. Okay, so this is about difference between numerical and algebraic expressions. Let's move on. On the next slide now, let's talk about like generating. If you guys remember the objective, we're going to generating equivalent expressions with any order and any grouping property. So that was a commutative property and associative property. So let's talk about these examples now. Let me clear out this. Okay, here we go. So the first thing, this is still I do part, so don't worry about writing down your answers. First thing, we need to rewrite 5x plus 3x and 5x minus 3x by combining like terms. So this is the key thing. What is a like term? Like term. Okay, so do you guys remember from 6th grade? No. Okay, let's talk about let's do the first one. When you say 5x and plus 3x, okay, so 5x means like 5 multiplied by x, right? But when you multiply with number and variable, you're not going to see the multiplication sign between them. So this is the very like invisible multiplication actually in between 5 and x. The meaning of 5x means like there are 5 x's, 1x plus 2x plus 3x plus 4x plus 5x. Okay, that's the meaning of 5x. Actually, the 5x is the shortest way to rewrite, like adding like 5 amount of x's like in this longest way. So we call this longest way like an expanded form. And the same thing for the next one. It's this plus now, the between, and you have a 3x. The 3x means you have 3 x's, 1x and 2x and 3 x's. Okay, so adding means you need to combine all of them. So in total, how many x's in this addition? Yes, 8 x's. Okay, so you just need to count them and writing down 8x. This is the shortest way to write them. So combining means putting all of them together or adding up. Okay, the number of x's, it's 8x. It's the same thing for subtraction, but this time it's kind of different. Let's say you have 5x minus 3x, right? So I'm going to go with text now because I need to be a little bit faster. X plus x plus x plus x plus x. And there is a subtraction sign, but this time I need to use a parentheses because there is a subtraction. So you shouldn't be get confused. Plus, oops, 3 x's. Okay. Here we go. So what do you think? So every time you cancel out 1 x's from previous one because you're subtracting. So this x and this x are cancels out, right? Or hold on, let me go with step by step. When you open up these parentheses, so these are the parentheses. So this negative sign makes everything inside of parentheses opposite. Do you guys remember that? So x plus x plus x plus x plus x, and this negative sign in front of parentheses reverses everything inside opposite. So it's going to be negative x minus x minus x. Okay, so we already know the fact that like when you add something with its opposite, so this is minus x is its opposite, they are cancel out each other or they become a 0. So these are cross out, and you need to cancel out like each pair, so positive and negative. So how many x's left? It's just the 2. Okay, so the other way to do this easily, because of like you just need to subtract the numbers, like 5 minus 3, which is 2, and you need to put the variables right next to it because these are the like terms. Okay, and let's move on. Okay, and the next example, it says find the sum. Sum means addition, 2x plus 1 and 5x. So for this example, like you cannot add up all of them. It's because like 2x plus 1 and plus 5x, because you need to add the together. So in here, the 1 is not doesn't have an x, so which means it's not the same kind, or they're not the like terms. Like terms means the terms that have the same like variables. Only 2x and 5x are like terms. So that means you need to add those like terms and leave the other term alone. We're not combining that one because they're not like terms. So you have 2x and 5x, they together become what? Because those are addition, plus 5x, it becomes 7x, right? And what is left? It's a plus 1 left. So you cannot add plus 1 with 7x because they're not the same kind, they're different. So you're gonna write it down as it is, okay? So this is the equivalent form expression of this addition, okay? And next thing, so find the sum for these numbers. Now this time, like a negative numbers are coming in. So we have to be very careful when negative numbers comes in, okay? So for this one, for example, negative 3a means like negative a, and negative a, right? And plus 2, because if you're trying to find a sum, you need to add this with the second expression, 5a minus 3. So 5a means like you have 5 a's, 1a, 2a, 3a, 4a, and 5a. Okay, and the last one is minus 3. Okay, so we know opposite quantities are cancel out each other, like negative a and positive a, negative a and positive a, negative a and positive a. How many a's left? We have only 2 a's left. Okay, oops. So we're going to start with the variable term. So it's a 2a. And next thing, you have positive 2 and negative 3. What's going to happen if you combine them? Positive 2 plus negative 3. Yes, thank you so much. Yes, it is a negative 1. Somebody told me online students. Yeah, thank you so much. Yeah, so you're the simplest form or equivalent form of this addition will be 2a minus 1. Okay, this is how we can combine or not combine. This is how we generate equivalent expressions when we have like this kind of addition or subtraction. Okay, so let's move on. The next slide is actually it's a trying. So make sure you guys type your answers in the chat box. I'm going to open it now. So here we go. What do you think when you combine these two like terms? Because both of them has a a's. What do you think? Got it. Thank you. Somebody, let's see if anybody also get this one. Okay, just one student. Okay, 2. Okay, awesome. So yes, it is you just need to combine the numbers like 3 and 5, which is 8, but you need to put the same variable that both of them has it, a and a. Okay, awesome. Thank you so much. For the next one, let's see. What do you think?
4b.
Okay, one hybrid student found it. Okay, couple. Okay, couple online students also, and we have more. Okay, so it's going to be 4b. You just need to subtract the numbers and put the same variable right next to it. Okay, and next one. What do you think now? It's getting a little bit more. Okay, I think everybody got it now. If there is a no number in front of variable, we count it as a 1, right? I think everybody figured. Oh, hold on, not everybody figured. Okay, only one student got it. Okay, so in front of variable, if you're not seeing any number, which means it's a 1. Because we know the fact like 1 times anything, like 1 times 9 is actually equal itself, right? It's 9 itself. So that's why we most of the time we're not putting 1 in front of that number. Or it's because when you multiply anything with 1, it's itself. That's why there is an invisible 1 in front of variable. Now everybody correct their answers. Thank you so much. It's yes, it is a 10c. Okay, so which is equal 10c. Whoops, not 10. I apologize. My 0 is very not great. Okay, so now we have these equivalent expressions, right? But now, if we know the values for these letters, what do you think results would be? For example, for the first one, the A is equal 2, B is equal 5, and C is equal -3. What do you think result would be for 8A? Somebody said it. No, it's not 2, because A is equal 2. Instead of A, if you put 2, what do you think result would be? Remember, okay, so only one person got it. 13. Let me explain one more time. So when you see like 8A, actually in between there is a multiplication, right? It's invisible again, because we don't want to put too many signs between them. And multiply with A, but we know the value for A as a 2. It's on the bottom, right here. So instead of A, we need to plug in 2 or replace 2. So only now a couple of students found it. Okay, it's a 16. So now think about the second one. I think you got it now. So for B, like if your B value is 5, what do you think result would be? Got it. Okay, now everybody got it. Okay, so means like instead of B, you're plugging in, oops, no, I apologize. It was a 5. Thank you. So it's a 20. And tell me the last one now. Instead of C, you need to plug in or replace -3. Remember, it's a -3. What is it? 10 times -3. Now you correct it. Thank you so much. So when you multiply any number with negative number, actually it becomes negative result, and not any number, I apologize. So positive number with negative number, result is always negative, and just it's going to become 30. Okay, thank you so much. Yes, you guys are corrected. Awesome. So this is kind of problem